Oh, you're going to like this one. All right, section 11.2, apply transformations to data, page 751. Are all the statistics of a data set affected when you transform the values in a data set? That means like add or multiply the values. So first thing I want to do is just refresh your memory about mean, median, and mode and standard deviation. You can do it off the calculator or you could do it by hand. So take just a second to do the warm-up. Okay, here's what you should have gotten. If you had added them, I took a second just to put them all in order here because sometimes it's easier to see these central measures of central tendency. So if you add them all up and divide by 7, you'd get 85.7. The middle value, you can see there's 3 on the outside here and 3 on the outside here. The middle value is 86. The mode, 87, occurs the most. The range is the highest number. Subtract the lowest number, that's 3. And the standard deviation is how far each data value deviates from the mean. So those are the numbers you should have gotten. You could also have done this by hand, which I'll refresh your memory on that in a little bit. So here's what you're going to do today. It's not much. Adding a constant to data values. When a constant is added to every value in a data set, the mean, median, and mode of the new data set can be obtained by adding the same constant to the mean, median, and mode of the original data set. The range and standard deviation are unchanged, so you got to keep that in mind. When you're adding a constant, the range and the standard deviation don't change. All right, let's see what happens here. The data below gives the weights of 5 people. At the end of a month, each person has lost 3 pounds. Give the mean, median, mode, range, and standard deviation of the starting weights and the weights at the end of the month. So if we had to do the starting weight, since it's only 5, we could easily do that by hand. Add them all together and divide by 5 and we get 146. If we put them in order, we can see that the middle weight's going to be 142 and the one that occurs the most is 155. The range is subtract the highest to the lowest, that's 17. And the standard deviation, of course you could get it from the calculator, but just to refresh your memory, all you have to do is you have to take the mean and subtract each particular data piece. So I'm going to do it 146 minus 138, square it, add to that 146 minus 140, square it, 142 minus 146. It doesn't really matter which way you do it because you're going to be squaring them in the end. 146 minus 155 squared, and 146 minus 155 squared. All of that divided by how many data pieces you have, which is 5, and then we would take the square root of all of that. And this is sort of derived from the distance formula on a graph. So if we did that all, I put that on the calculator, you would get 7.46. It's the same thing that the calculator would do for you. All right? So I'm going to actually just show you that you can put those numbers on the calculator. And I already have them on here. I'm going to clear this list out. Okay, so here it is. There they are on my list. And if I went through the stats, I would get all these same numbers that we just did. Now, this right here says if I'm going to take away 3 from each of these, I can also take away 3 from the mean, median, and mode. Just subtract. And it would turn out to be the same thing as if I did it all longhand. However, the range and the standard deviation do not change. So, just to check that we did it right, we could actually do it on the calculator too. If you have the original data set entered under list 1, I could go up and highlight list 2 and tell the calculator, okay, for my list 2, I want to take list 1 and I want to subtract 3 from each data set piece. And there's the numbers subtracted by 3. 135, 139, 152, 137, and 155. So it's all in there. Now what I'm going to do is I'm just going to check to see that these numbers here are really accurate. So go to Stat, over to Calc. I want the calculator to work on these statistics. I'm going to tell it to read from list 2. And if I compare to my numbers here, I should have the same thing. The mean is 143. If I arrow down to the median's 139, the mode is 152, the range, you take the max, which you can't see here yet, the max minus the min is 17, and standard deviation, let me find that, is up here, 7.46. So it works. Pretty nifty. All right, flip it over, backside. Look at how little it is. So before we added or subtracted an amount from each data piece, here we're going to multiply the data values by a constant. When each value of a data set is multiplied by a constant, the new mean, median, mode, range, and standard deviation, oh here we go, this includes range and standard deviation, can be found by multiplying each original statistic by the same constant. So we're going to use the same numbers that we had before. Give the mean, median, range, and standard deviation for the starting weights of the 5 people in the previous example in kilograms. So we have to convert them to kilograms. And right here is the conversion that we need. 1 kilogram is 0.45 pounds. Well, this says I really don't need to do it all by hand. All I have to do is multiply the mean by 0.45, the median, the mode, the range, and the standard deviation from these numbers right here. So if I did 146 times 0.45, I would get 65.7, because it's just under half, so that kind of makes sense. And then the median times 0.45 is 63.9, and all the way across, everything times 0.45. Now if you wanted to double check, of course you could do it by hand, or we could just go right back here and we could edit the list. So I'm going to clear this list, and I'm going to say, okay, now for my list 2, I want to take my original numbers and multiply them by the first list times 0.45. And those will be my new numbers. And then I want to find the mean, median, and mode from that list. And so if I go to Stat, Calc, Enter, tell the calculator to read from L2, and then let's just see if they match up. Look at that. The mean, 65.7. The standard deviation is 3.36. which is right there. Hopefully you can see that. And then the range is going to be 7.65, and the median is 63.9. So we are right on. And that is the fastest video ever.